Good afternoon, everyone. Today we will learn the structural analysis one subject. And what we have to learn in this subject, let's see what are the different learning points we have to cover in this module. These are the 4 points we have to cover in this module. The first is assumptions of structural analysis. Second, introduction of analysis of arches. Then the different types of arch, that is 3-hinge arch and 2-hinge arch. We'll cover all with respect to concepts, types and the analysis. For this present module, we will learn only the assumptions of the structural analysis and the introduction of the analysis of arches. What we have to learn in this modules today? In the second chapter, analysis of arch, we'll see the different nomenclatures used in the analysis of the arch. Then what are the different types of arches? It means the classification of arch. Then why we are using this arch in the structural field, that we have to cover today's module. So let's start with the assumptions of structural analysis. So the assumptions of the structural analysis to understand the structural analysis field. So the fundamental assumptions of the structural analysis, the first assumption is the body is assumed to be elastic. Then the second assumption is the body is assumed to be an homogeneous. It means the body has identical properties in identical direction at all the points of it known as an homogeneous. Then the body is assumed to be isotropic. It means if the body has identical properties in all the directions at a point is known as isotropic. Then the next assumption, that is a body is assumed to be solid continuous structures. It means there is no voids in the body. Then the principle of superposition is valid is the next assumption. What is the principle of superposition? The combined effect of the force system acting on a rigid body is the sum of the effect of individual forces. We already learned in the engineering mechanics this principle. If we write it mathematically, then the combined effect of the force system, for example, this is the combined effect of the force system P1 and P2. These are the two forces. This is a combined effect of the two forces is nothing but the sum of the effect of two individual forces. Say like this. So this is called as the principle of superposition, and the Saint-Venant principle should be valid. These are the assumptions used in the structural analysis. So we will move forward the next topic, that is the introduction to the arches. So see the figure. This is a typical bridge arch constructed on a river, and support this arches is supported on the piers and the abutments. So we'll see the different nomenclatures used in the arches. So let's start. The first key element is your crown. This crown is nothing but the topmost point of the arch is called as crown. This, if you see this figure, at this location there is a crown. Okay. Then the next point is your extrodos or back. Extrodos back is nothing but the exterior curve of an arch is nothing but the extrodos, or also is called as back. Then the next term is your introdos or soffit. Is nothing but the interior curve of an arch is called as introdos, and the interior surface of an arch is called as soffit. Also, the exterior surface of an arch is called as back. That is the meaning between the extrodos and back and introdos and soffit. The next terminology is your central rise. Central rise is nothing but the vertical distance. This is a vertical distance from the springing line to the crown. This is a crown and this is a springing line. So in that, between that distance is called as a central line rise, also denoted by small h. We will see afterwards. Then the abutment. The arch is supported or abutments or the piers If the arch is supported at the end of the bridge, if you see the figure, if the arch is supported at the end of the bridge, that is called as abutment. And if the arch is supported intermediately, these are the intermediate points, this is called as a piers. These are all piers. So these are the nomenclatures used in the arches. One geometry is left, that is the springing line. What is this springing line? The springing line is nothing but the imaginary horizontal line joining the two springing points. This is an horizontal imaginary line joining the two springing points. What is the springing point? These are the points from which the curve of the arch is springs. The curve is springs. These are the 2 points are springing points. These are the nomenclatures used in the arches. So we'll move forward with the classification of arches. So the classification is based on an architectural point of view and the structural design point of view. If the arch is classified at architectural point of view, then arch is classified as circular arch, parabolic arch, elliptical arch or straight arch. And if it's based on the structural design point of view, the arch is classified as you shown in the figures: fixed arch, 2 hinge arch, 3 hinge arch and tied arch. And these are the classification is based on the structural design point of view. I hope you understand this classification. Then we move forward with why we construct, what are the reasons behind to construct this arch. The first important reason behind this is the better utilization of the material, which is strong in compression and weak in tension, because arches are predominantly subjected to an axial compression forces only. Then second, for the last size openings and the span, that's why we are using the arches. Then next, for the better aesthetic and for the cultural representation, that's why we are using the arches in the construction. Then we'll discuss about what is the bending moment in the arch is get reduced. It reduced to the value 0, considering a simply supported beam. For example, if you draw a simply supported beam like this, carries an uniformly distributed load W, and these are the supports of the simply supported beam. If you find out this reaction at the support, we'll get the value WL by 2 and WL by 2. Spanning between these two arches L. If you find out the moment about some axis XX at a distance x from A, say this is A and this is B. If you find out the bending moment equation about an x, it's very simple to write the equation by using WL by 2 into x minus WX square by 2. This is the bending moment equation about the section XX. Now we have to find out the same bending moment equation about XX in the arch. So for that we have to draw first the arch. See, this is the arch, has the hinge support, then carries an uniformly distributed load, is W. Then the reactions, if you find out, for example, these are the horizontal force at that point and horizontal force at that location. Then the reaction about these points are WL by 2. This is also WL by 2. Then the spanning between this is L and the central rise is H. If you consider about this location XX, you need to find out what is the bending moment equation about that xx. For example, this is your x, this is your x distance, and at that point this is your y location, y distance. Now you have to find out the bending moment equation about that xx. Then we will get the value, that is WL by 2 into x, this WL by 2 into this x, and this bending moment produces a sagging bending moment, so it is plus. Then this horizontal force Hy, before that we have to deal with this W, so minus Wx square by 2 about this xx section, it produces an hogging bending moment, that's why it is minus, and this Hy again produces an hogging bending moment about section xx. If you see carefully, this term, as you already seen in the bending moment equation previous, here this term is nothing but the bending moment about xx in simply supported beam. Can I say this is the simply supported beam bending moment? So bending moment simply supported beam minus Hy. So it clearly says that it means the lateral reactions, these lateral reactions are mandatory for being an arch. It reduces the bending moment in the section of arch, but amount of Hy. This is an amount of Hy. So this is a main conclusion from this analysis. I hope you understood this concept, why the bending moment is reduced in the arches. If you draw this curve and supported like this is a simply supported beam, then there is no restriction in that location, there is no restriction at that location. It means this is a curved beam in elevation. This is not an arch, but this type of, if it's supported on the two hinges, not a roller support, only hinge support, then this structure is called as arch. Why? Because there is a restriction in the lateral direction. This is the basic difference between the curved beam in elevation and the arch. I hope you understood this basic terminologies and the basic concept of an arch. Thank you for watching. Have a nice day. Jai Hind.